So that will be my talk about one of my favorite technologies that emerged in recent years. I'm Gaetano, and I work for YLD as a contractor and have my own startup focusing on developer tools. And that said, I always cared about two things: efficiency and developer experience. And as someone with a multicultural background, I was always taking care of or thinking about language and how language shapes the way you think. And that said, GraphQL offers a nice way to describe your problem, and as a client, as an API consumer, describe what kind of data you want and how you want it served. So we will be talking about the problem in general, designing APIs and writing clients that interface with the API. Then I will introduce it with a problem and then show how GraphQL solves this problem. So many of you guys probably heard of GitHub, and if you want to get data from GitHub, they provide you a nice API where you can query the stars of a repository, who contributed to a repository, and then also more various information about the users, like their location, where they live, or what projects they contribute to. So as an experiment, we could think of following scenario. We want to get the locations of every contributor to a certain project. And GitHub provides a REST API, and so how it would look like is, first you make a GET call to the repository of your choosing and / contributors, and then you get a list like this, more or less. And once you have the names of the contributors, you move on and ask about details about the specific user. And then we extract the location, which is what we are interested in. But unfortunately, if we want to do it 100 times, then we probably also need to invoke the endpoint for getting the contributors multiple times, because they implement pagination for performance reasons, because usually there are thousands of contributors and you don't want to serve all of it at once to every client. So we will go back and forth and ask a list for contributors and then ask about the individual user. And very quickly we end up making more than 100 requests. And even worse, those APIs provide a lot of data. So here is this is how one request looks like. This is the response, and it has over 2,500 characters, 2,500 bytes. And what we actually are interested in is just the location, which is just around 100 bytes, resulting that we, on every request 20 times more data than we actually need. And this problem arises from the fact that we're not able to express exactly what we want. Ideally, it would look like something like that, the response of the server, which has nicely just the things that we are interested in. So to summarize, using a REST API, it's really hard to design an API that fits all the use cases for everyone. the challenges are to get enough data, to serve enough data, but also not to serve more than needed. So if we look back at our ideal response, this is something that could be achieved quite easily when you would use a GraphQL endpoint. And so the client would then specify a query describing what he wants. And this is how it would look like. If you squint, you will see that it looks like JSON. It also has a couple extra features. It has a notion of function calls where you can parameterize your fields. For instance, here we say there's a notion of projects, and you can access them by name, and then contributors, we can limit it by the number we are interested in, and then we say we are only interested in the users, their names, and their location. And as a matter of fact, GitHub and many other companies switched for this very reason to GraphQL. And they also offer a nice IDE where you can experiment with their endpoint. And the nice thing is not only that you can just test your queries, but also because GraphQL is a typed language with a schema, documentation is automatically generated. So you can explore what those individual fields provide and then compose your query. And this is how the schema would look like on a server. So we describe here our endpoints, in this case how to get a project and a user, and those return data of a specific type that is described below. And if you want to write a server using a GraphQL, providing a GraphQL endpoint, all you need to do is write a schema and then write so-called resolvers. There are generic functions that are invoked as soon as the client requests a particular type. So if the user requests contributors, this function over here will be invoked, and then you can do whatever you want to accomplish the retrieval of this data. And the interesting thing about this is, and that's why it's called GraphQL, it builds up, based on your query, a graph. And on every node, it basically invokes a function. And the function gets the data of the previous node. So you can basically nest your data. If we go back to the query. So basically, if you request for a project in the resolver, you will return the data associated to a project, and then the resolver for the contributors receives the project data that you retrieved, and then you can use that to get the contributors. And this is how, for instance, such resolver would look like. If we have a contributors map, for instance, then a get contributors function would look like this, for instance. And once you have those things set up, GraphQL is able to go on a scavenger hunt to get all your data, and it will only go for the fields that the client specified. And the shape of the return data matches the query, so it is perfect for the client's consumption. And yeah, if you want to build the GraphQL endpoint, all you need to do is to call one function and pass in your schema and your resolvers. If you are prototyping, it turns out that they offer also a convenient add mock functions to schema method, which creates resolvers for you that return random data, so you can start experimenting and iterating over your schema before you start building resolvers. And if you want to use Express as your HTTP server, this is how you would use the GraphQL executable schema. But the nice thing about this is it's protocol agnostic. So if you want to go serverless, all you need to swap out is Express with your framework of a serverless framework. You can also use WebSockets and stream the data. GraphQL is only taking care of getting the data and interpreting the query of the client. And interestingly, there are more features that GraphQL offers. So via so-called annotations, you can specify, for instance, how long things should be cached, which then the client or the server can leverage to optimize the function calls. Often people ask about authentication. For that as well, you can offer an annotation and then provide an annotation in the shape of a resolver that gets invoked if this field is available. And often you end up to have very deeply nested queries, recursive queries. There is this nice framework that can be used for GraphQL, but also for any other server-side setting. It's called the data loader. It's a library developed by Facebook, and all it does is it creates a memorize function where you provide a function that takes an argument and invokes a function. And what it does is for every argument, it will store the result, cache it, and every function call will return the same promise, which leads to the fact that if you do a database call, for instance, those calls will be batched, meaning that you will result to only one call to the backend, which might increase performance. Then another interesting thing is another framework that takes your GraphQL schema and translates it to classical SQL. And using that and the query of the client, you can compute the optimal SQL query for your relational database. I don't have much code about it, but this is how it would look like. So for an example query like on the right, on the left, it would create a select statement that fetches all the data that you requested. And that's from my side. If you have any questions, I'm here.
Hi, so if you've got a REST API, then probably what is underneath that is just like straight, probably somewhat optimized select queries at the database layer. What is the performance like of GraphQL? It sounds like obviously there's more complexity there, and is that actually a factor, or is it quite fast?
So the schemas can be compiled, which increases the performance. But yes, there is an overhead of interpreting the query. I'm sure you can optimize that by just caching the same queries, like the shape, but yes, there is an overhead. I can't tell you any numbers about it, but I think if that's your concern, then you might like to stick with REST. GraphQL offers you flexibility at its price, so it's perfect if you don't know how your clients will consume your endpoint, or if you yourself have many REST endpoints you want to communicate with, and you want to just collect the data and denormalize and ship it to the client.
Thank you for your talk. Could you go back a couple of slides? My question actually is the slide with the type project at query.
The query or the schema?
This one. My question was mostly around the at cache max age is 100. So when that's passed back to your resolver, because that's essentially a parameter.
This is actually the schema you define on the server. It's not the query the client sends to you.
Oh, okay, so but when max age is passed back, is that passed back as a number or a string or what type?
GraphQL is typed. This is a number, so you will receive it on your in your JavaScript as a number. Interestingly to note, those annotations, they are all user-defined, so you define the semantics of those. Luckily for cache, it's already built in.
So if I wanted to turn max age into, for example, a special type of object that I wanted to create, I could do that easily. I would just have to do it.
Anyone else? Question? Okay. This is the final one as well.
You mentioned about compiling before, but as I understand it, for the client, it's quite flexible. You can be able to choose the graph layout as it comes. Like, how do those two go together? Because like normally compiling is designed at developer time.
So there are schemas on the front end, on the client, and also a schema on the server. The server needs to associate every type, every field with a function, and this can be compiled ahead of time.
Okay, and that still leaves the flexibility on the front end to mix and match as it suits them?
Yeah, so this is given. It's basically reduced to just a mapping between type name and a function. And so when it runs through your query, which is the interpretation step, which cannot be compiled, it will match those types and functions and then go on the scavenger hunt. So this is something that you cannot eradicate.
Okay, awesome. Thanks so much for your talk.